This is our intro video for AP Calculus AB, section 3.4. We're going to be looking at concavity in this video, and then later on in section 3.4, we'll be looking at the second derivative test. So, concavity. We're going to be looking at just basically two different categories of concavity. So let's take a look at our first couple of statements here. If f is continuous on an open interval, and statement number one, if f prime is increasing, then f of x is concave up, or if f prime is decreasing on that interval, then f of x is concave down. So we're going to look at some graphs to help illustrate this a little bit. So over on the left you have the graph of f, and let's just think about how f prime is going to change over time here. So for example, let's look out here on the left end point. Right here I'd say, f prime is clearly negative. Maybe we could just say it's -1. It's probably something different than that, but we'll just say that it's -1. Well, if that's true, then right here, f is still going downhill. F is still decreasing, but it's not as steep, right? So I would say f prime is maybe -0.5, something like that. And of course, right in here somewhere, that would be where f prime is equal to 0. So as we go from left to right, you can see that f prime went from -1 to -0.5 to 0. That's an increasing pattern, isn't it? Right? -1 to -0.5 to 0 is increasing. And I think we'll see that pattern continue. Maybe right here. There we go. Right at that point, we might say that f prime is 0.5. And maybe out here on the end, it's not quite as steep. Maybe we say that f prime is 0.75. Something like that. So you can see again that pattern in f prime is continuing on. You can see that for this whole interval on this, f prime is increasing from -1 to -0.5 to 0 to 0.5 to 0.75. That's clearly an increasing pattern, and you can see what goes along with that is that the graph of f is concave up. The concavity that you see through here is facing up, concave up. Just for sake of argument, let's take a look at the graph of f prime as well. We've done much of this type drawing before, so I'm going to just draw this out here real quick. F prime is 0, we noted, when x is 2 approximately, so I'm going to do this. And to the left of 2, f prime was negative, correct? Well, it was like -1, -0.5, something like that. So I'm just going to say that f prime has to be below the x-axis. And then as we noted that to the right of x equals 2, f prime goes to being positive. So maybe something like that. So you can see, again, using the graph of f prime this time, we can see the idea that f prime is increasing, and we can look back at the graph of f and see that that means that f is concave up. All right, as we follow along in the notes here, we can see that the next series of graphs deals with a graph being concave down. So we'll go through this a little bit quicker, but if you remember from before, if f is concave down, then f prime must be decreasing. And we can see that the graph on the left there is a graph of f, and it's clearly concave down, right? The concavity is facing down. And we think about the values of f prime. So right here, f prime is going to be pretty close to 0, right? And then over here, f prime is going to be, let's say, -0.3, right here. F prime is going to equal like -1. Over here, it's very steep. Graph of f is maybe f prime equals like -6 or something like that. Bottom line is, you can see that as you move from left to right, f prime is decreasing, and that goes along with f being concave down. The graph of f then, you know, the whole graph here, other than maybe the left endpoint, has a f prime value that's negative. So, you know, maybe over here, what do we have? 1, 2, 3, 4, about 5. So right about here, I'd say that would be where we'd start. And then we're going to have that nice decreasing pattern all the way across for that graph of f prime. Again, if f prime is decreasing, then f must be concave down. We're kind of looking at it from two different perspectives here in terms of just f prime. On our next slide, we're going to look at how f's concavity is described by f double prime. All right, so we looked at how f's concavity is described by f prime just a second ago, and now we're going to look at concavity of f in terms of f double prime. So take a look at these two statements. We'll do an example or two here in a second. So if f double prime is positive on an entire interval, then the graph of f is what you would think probably, concave up. So if f double prime is positive, then f is concave up. And then if f double prime is negative, then the graph of f is concave down. And there is a kind of an easy way to remember this using the smiley frowny face thing. So this would go with statement number 1 if f double prime is positive. So we're going to start there. We're going to start off with f double prime. That's going to be the nose, right? That looks like a double prime. If f double prime is positive, we're going to make the eyes positive. So far we have 2 eyes and a nose and a creepy smiley face. There you have it. If f double prime, that's the nose, is positive, that's the eyes, then the smile is concave up. And then of course, if we want to look at the other case, it's going to be a similar looking face, but maybe not so weirdly happy. Once again, we're looking at f double prime. But this time f double prime is negative. So this person is either sad or mad, maybe. And the smile is concave down. It's really not a smile. Oops, really not a smile anymore. It's more of a frowny face. So again, f double prime is the nose. The eyes are indicating f double prime is negative. And we got the frowny face to go with that. Okay, just a way to remember things. If that works for you, great. If you think of a different way, then of course that's great too. So we're going to do an example here. Example number 1 says determine the open intervals on which the graph of f is concave up or concave down. And so let's take a minute and think about what we'd need to do here. If we're going to use f double prime to help us with this, we need to find f double prime first. So let's go ahead and do that. So I've got f prime. I've got to get f prime first if I'm going to find f double prime. So f prime is equal to negative 3x squared plus 6x. And then f double prime is equal to negative 6x plus 6. So if I'm trying to find out where f is concave up or down, I need to find out where f double prime is either positive or negative. So what number separates the positives from the negatives? Of course, that's 0. So I'm going to set f double prime equal to 0. This will give me an idea of where to set my intervals. So when I solve this, I end up with x is equal to 1. So I'm going to turn back to an old friend, the sign chart, except this time my sign chart is going to tell me something about f double prime instead of f prime. I'm going to go ahead and put my 1 on there. And all I really have to do here is test the interval to the left and the interval to the right. So over on the left, I will use 0 as a test value. So I'm going to write f double prime of 0, and that's equal to 6. And then maybe I use a 2 over here. F double prime of 2 is equal to negative 6. So over here, f double prime is positive, and over here on the right, f double prime is negative. So what I can then do is say confidently that f is concave up on the interval negative infinity to 1 because f double prime is positive on that interval. And I can also say that f is concave down on our other interval, which would be 1 to infinity, because f double prime is negative on that interval. Okay, we're going to do a quick check for understanding here in a minute, but that concludes the main part of our video. All right, with this check for understanding, I would encourage you to try this on your own and then watch the video to check and see how we did. So the question says, determine the open intervals on which the graph of g of x is concave up or down if g double prime is equal to that function right there. So this is a little bit different than the example we just did. Maybe you've noticed already, but let's go ahead and talk about concave up or down and what that means. So if g of x is concave up, that means that g double prime is positive. If g is concave down, that means that g double prime is negative. So if we're trying to determine the answer to this question, we're going to need to have g double prime. So one way this is different from the other question is, the other question we had to actually figure out what g double prime was, or maybe it was f double prime in the other one. Here, g double prime is simply given to you. So it's an important thing for us to note here. Sometimes you'll be given something that maybe you don't expect, so double check to make sure that you understand what you have and what you're trying to find. Okay, so in order to get an idea of the intervals we'd want to consider, we want to set g double prime equal to 0. And we can see if we set g double prime equal to 0 and solve, we're going to get three values. We're going to get x is equal to positive 4, x is equal to positive 1, also x is equal to negative 2. So those are going to be our three values that determine which intervals we consider. So I'll put those on a sign chart again. Negative 2, 1, and 4, and this will be a g double prime sign chart. So like we did before, I'm simply going to do some test values and determine what's going on. Be careful, we got some repeated factors and the multiplicity thing might make a difference here. So, maybe we try over here like a negative 3, so it'd be g double prime of negative 3. I'm not going to be real concerned about exactly what the number is. I'm only going to be concerned really whether we're positive or negative. That's going to be the main thing here. So let's see, if I plug in a negative 3 in here, I'm going to get a negative number. Let me make that a little bit more clear. I'll get a negative number for that factor. I'll always get a positive number for that factor because of the squared. And then I will get another negative number there. So I'm thinking this was going to be a positive. So I'll just put a plus right there. Right here, I would try out a 0. And if I try out a 0, let me erase these right here. If I try out the 0, I'm going to get a negative, again a positive, and then another positive. So that's going to be a negative there. And maybe here I try out a 2, so it would be g double prime of 2. So I do plug in that 2. I'm going to get a negative, a positive, and a positive. So once again, we're negative there. If you understand multiplicity, you were maybe expecting that. And then finally over here, maybe we try g double prime of 5. So g double prime of 5 is going to give us a positive, and a positive. So we can then say that g is concave up on a couple of intervals, negative infinity to negative 2, and let's use the little union symbol there, 4 to infinity. G is concave down on, well, really, negative 2 to 4. You can list that as just one interval. Of course, we were not asked to justify our answer here, but if we were, we would want to mention that g is concave up because g double prime is positive, and g is concave down because g double prime is negative. I hope that went well for you. We'll practice some more of these when I see you in class.